Hello, Algebra 2. It's Mrs. Avila here, and we are going to wrap up our statistics unit today by talking about methods and ways that you can collect data. All right. Now, when a statistical study is conducted, the general steps are as follows. You first have to identify the variable that you're interested in learning about, ideally about a particular population. Then you need to make a point to choose a sample that is representative of that population. We talked previously about if the sample doesn't represent your population accurately, then anything you do from this point on won't really be helpful for answering your initial question. Once you have your sample, you will then collect data. Then, as you get data coming in, you can organize and describe the data using the statistical measurements, maybe the sample means or sample proportions, sample standard deviations. Once you get all this information collected and the numbers that represent your sample data, you can then try and interpret the data, try and draw inferences. Remember, that means to draw conclusions about the larger population, and hopefully be able to use the information to not only learn something, but maybe make some really good decisions about whatever it is that you're studying. So we're going to break this up into kind of three parts today. The first thing we're going to talk about is sampling methods. Now, as always, if you don't have the notes in front of you, maybe please pause the video, take a minute to print them off, or get out a sheet of binder paper so that you yourself can write down some information. Okay. Now, when I say sampling methods, really all I'm referring to is the ways to select people or things to be in your sample. Okay. Now, there's several sampling methods that are available. I'm going to talk about each of them, try and give you an example, and talk about the pros and cons of each. The first is called voluntary sample. This is when members of the population can volunteer to be part of your study. For example, flyers are put around campus asking for students who are willing to participate in a taste test experiment, or posting a phone number for people that are interested to call and then volunteer to be part of your study. Voluntary sampling is one of the easiest sampling methods in regards to the person carrying out the study, but it's also naturally biased. Biased means that it is in some way going to hinder or affect the results to not necessarily be accurate for what you're trying to learn about. All right, now our second sampling method is known as convenience sampling. This is when only members of the population that are easiest to reach are selected. An example of this is if a booth is set up downtown to survey residents on their opinions about the new downtown renovation plan. People are asked to participate as they walk by. You only really have access to people that conveniently happen to be downtown at the moment, and so this is known as convenience sampling. Another example I oftentimes give is if people were at the outlets or the mall. Let's say you're giving a survey and you choose to stand in front of Forever 21 versus maybe you decide to stand in front of Champs. Okay, you're going to get very different samples probably just by pure convenience as to who tends to visit those types of stores. Now, voluntary and convenience sampling, although they both are two of the easiest sampling methods, they require the least effort by the person doing the study. They unfortunately both are not good methods. You can do them, but unfortunately, they will typically cause your samples that you select by using them to be biased and therefore cause issues in then being able to make inferences from the data collected from them. Our next sampling method is called systematic sample. Systematic sample is a rule is used to select members from a population. For instance, selecting every other person. Another example I give here is a store employee stands at the exit of a checkout area and hands a survey to every fifth customer as they leave the store. There's a systematic element to it. It's not just random. There is actually a method and a very system type way of selecting people. We could do this at Granada High School if we were all back on campus, and we could maybe, if we were trying to learn about seniors, potentially standing by the student parking lot and handing out a survey to every 10th person would be a good way to do systematic sampling. Our next sampling method is called stratified sampling. Stratified sounds very similar to a couple of the other methods that we're going to be talking about. So I'm going to try my best to clarify the difference. Stratified is if a population is divided into smaller groups called strata, and they're broken up into these groups based on some type of characteristic, so some type of similar characteristic. A sample is then randomly selected from each group to collectively make up the overall sample. An example of this is, let's say I want to survey all different grade levels at Granada. So I randomly select 100 students from each grade level's roster. These 400 total students become my sample. Instead of taking the entire Granada High School student list and randomly selecting 400 students from it, if I do that, it is possible that I could potentially get a majority of my randomly selected students from a particular grade level and maybe very few students from another. Maybe I get a lot of seniors, but very few freshmen. Okay, so stratified is really nice if you want to make sure if you get several different types of groups without missing out on anybody. Our next sampling method is called cluster sample. Now, at first glance, cluster sampling and stratified sampling sound very similar, so I'm going to try and distinguish the difference between them. Cluster sample is a population is divided into smaller groups, very similar to strata, but in this point we call them clusters. Then at that point, all the members in one or more of the clusters are selected. So this example is, let's say I want to survey Granada students, but I can't make it around to all third period classes fast enough on a Wednesday. As a result, I randomly select 8 teachers and pass out surveys to all the students in those 8 classrooms. So stratified random sampling and cluster both break up the population you're trying to learn about into smaller groups based on some type of characteristic. It could be grade level, it could be classroom. Stratified, however, then goes into every single one of those groups and randomly picks out maybe like 5 or 10 of them. Collectively, all of those students now become your sample. Cluster, instead of going into every single group and picking a random selection out of it, they're going to randomly select a couple of the clusters, and those clusters and everybody in them will become part of your sample. That means the clusters that are not selected, none of the people in them would become part of your sample. And that brings us to our last type of sampling method. It's called random sample, or you'll hear it referred to as simple random sample, or an SRS. This is known in statistics as the best sampling method. A random sample is if each member of the population has an equal chance of being selected. For instance, the names in the class members put into a hat and 2 are randomly pulled out. A lot of times you'll see random sampling done by assigning a number, for example, to represent each senior at Granada, and apply a random number generator to select 5 to lead the Pledge of Allegiance. Okay, so randomness is really what we want to make sure we have when we do sampling. Randomness better allows our sample to not be biased in some way, to purposely leave somebody or some particular group out, or over-represent a particular group or type of people instead. So SRS, simple random sample, or random sampling, is known as the ideal, helps reduce bias. All right, so we're going to try a couple. This says sampling methods and ways to select people or things in your sample. I gave you a few scenarios, and we're going to try and identify which sampling method is being described. Okay, so this says you want to determine whether the people in your neighborhood like new social media website that provides updates. Identify the type of sample and explain why. Number 1, you ask all the neighbors on the block where you reside. So we have several sampling methods as options. We want to look at our list and try and figure out which one this sounds like it's being represented. If you said convenience sampling, you are correct. Convenience sampling in this case makes sense because you are purposely just picking the people that are easiest for you to reach. Some people might say cluster here, except we are not randomly selecting our block. We are purely picking it just because it's where we happen to live. Number 2, you randomly select a neighbor from each block in your neighborhood. So in this case, if you think stratified sampling, you are correct. The key is I'm breaking up the neighborhood into blocks, and then I am randomly selecting one neighbor from each of them. It would be cluster if instead of selecting one neighbor from each block, if I randomly selected a block and surveyed all the neighbors in that particular area. And number 3, you email a questionnaire to each and use only the questionnaires that are returned. So you email a questionnaire to everybody, but you only get the questionnaires that are returned back to you. This would be voluntary sampling. Anytime you've ever gotten something in your email or mail and they're clearly hoping that you take the time to fill it out and return it, this is voluntary. They're sending a really wide net, hoping that they get a good amount of people taking the time to volunteer their time and send it back. There are a few you-tries on your paper that you can go ahead and pause and try to identify the sampling methods, and then we're going to jump into biases. All right, biases are really important to understand in statistics because they can either make or break whether or not the results of a survey or study have meaningful results. Now, a bias is an error that results in a misrepresentation of a population. This can be done a lot of different ways. A sample that overrepresents or underrepresents part of the population is a biased sample. When a sample is biased, the data is in turn invalid. In order to obtain reliable information and draw accurate conclusions about a population, it's important to select an unbiased sample. Basically, it's important to make sure you pick a sample that is representative of the population you're trying to learn about. A random sample, as we mentioned earlier, can help reduce the possibility of a biased sample. A lot of people ask, if you use randomness to select your sample, does it guarantee you have an unbiased sample? And that is not necessarily true, but it can help reduce the chance that you have a biased sample. So we're going to look at these scenarios and we're going to try and identify the type of sample and why it's biased. Why could this particular scenario cause a biased result? So number 1 says, the principal asks students at one lunch table about the quality of food served in the school's cafeteria. So the question is, what type of sample was done and why would that potentially have some biased results? If you thought cluster because the principal asked one particular table and all the students at it, you are correct. Why would this potentially cause biased results? It's very possible students at one table may have different opinions than students at another. Think about it. A lot of times you sit with your friends, and when you sit with your friends, you talk. Sometimes people share common opinions or voice their opinions to each other. You also might be more likely to agree with a friend because you agree with them maybe on other fronts as well. Number 2, a sports announcer wants to know how often people in town attend community sporting events. She asks every 10th person in attendance at a local soccer game. So we want to know what type of sample and why could it potentially be biased. Here I would say systematic because she asked every 10th person. How could this be biased? Well, she's literally asking people at a sporting event if they go to sporting events and how often. People who didn't go to the soccer game didn't have an opportunity to be surveyed, and so maybe people that don't attend as many sporting events are going to be less represented in the sample. Number 3, you're in charge of the senior class prom. You want to poll the members of the senior class to find out where the prom should be held. There's 415 students in the senior class. Describe a method for selecting 70 seniors to poll. This is a little different because it's not necessarily asking you for a sampling method or a bias. It's asking how could you select the 70 seniors. If you want to try and reduce bias, as we mentioned earlier, random sampling would be key. So how I could describe selecting the 70 seniors, I could, let's say, make a list of all 415 students or get one from the front office, assign numbers 1 to 414 to each student, and use one of those random number generators like Randint or a computer program in order to randomly select the 70 seniors. Fun fact, if you have a graphing calculator, you actually have a command called randint, and you can actually do random sampling with this command very, very easily. Go ahead and pause the video and try these 3 problems. Again, feel free to check the key to verify your answers. All right, so we've talked about sampling methods, we've talked about biases from different sampling methods. Now let's talk about methods of actually collecting data. So there are a couple different options here. One is an experiment. An experiment, the key part of defining an experiment is the fact that an experiment imposes a treatment on individuals in order to collect data on their response to the treatment. If a study does not have a treatment imposed on the subjects, then it by definition cannot be an experiment. Okay. A treatment may be something like a medical treatment, or it could be any action that might affect a variable in the experiment, such as adding methanol or gasoline to gasoline, and then measuring its effect on fuel efficiency. It could be giving a particular medicine to somebody and seeing how their headache pain is affected. You typically see experiments when you want to see some type of cause and effect. Another option besides experiments is an observational study. An observational study simply observes individuals and measures variables without controlling the individuals or their environment. This type of study is used when it's difficult to control or isolate the variable being studied, or when it may be unethical to subject people to certain treatment or withhold it from them. Observational studies are when someone goes out and simply records information. It could be of people in a particular environment, or it could be people, let's say, their habits maybe in terms of commuting. I'm not necessarily controlling anything about how they commute or what means that they get from one place to another, but I'm observing what people are already doing and recording that information. A third method of data collection, one that you have all probably taken part in at one point or another, is a survey. A survey is an investigation of one or more characteristics of the population. In a survey, every member of a sample is asked one or more questions. They can be asked on paper, online, or even an in-person interview. And last but not least is a simulation. A simulation uses a model to reproduce the conditions of a situation or process so that the simulated outcomes closely match the real world outcomes. You see simulations done a lot in terms of experiences like pilot training or military training. You might even see simulations done when a new bridge is being built and they're trying to simulate traffic and figure out how many toll booths that they need to have set up. So this says, identify the method of data collection each situation describes. Number one, a teacher records how many students enter the classroom and turn in their homework before sitting down at their desks. Well, would it make sense to impose a treatment here? Simply observe what happens, survey the students on whether they came into class and turned in their homework, or simulate the results. In this case, I would say observational study makes the most sense. You can simply observe students enter class and whether or not they turn in their assignment. Number two, a manager uses a computer program to predict how many defective. Oh, the suspense is killing me. I think I lost part of the question. How many defective products can be expected on a particular assembly line? Okay, it's not actually doing the assembly line. It's not really opposing a treatment and not observing a assembly line. Simulation makes most sense in this case because he's trying to simulate or make up a little scenario where they can kind of observe what would likely happen based on a certain situation. Go ahead and try these. Again, you're identifying what method of data collection makes most sense, and then go ahead and check your answers on the key. All right, and to wrap up this very thick vocabulary, kind of conceptual lesson, we're going to finish talking a little bit more about surveys. This is because this is going to be very important in regards to your essential Unit 3 statistics assignment that you are going to be introduced to next week. Now, when designing a survey, it's important to word survey questions so that they do not lead to biased results. Not only can your sampling method cause biases, but the survey itself can cause biases. Answers to poorly worded questions may not accurately reflect the opinions or actions of those being surveyed. Avoid questions that do the following: encourage a particular response. These are known as leading questions. Do not provide enough information in order for somebody to give an accurate opinion, maybe vague questions. are too sensitive to answer truthfully. Maybe that survey should be anonymous so that people may be more honest in their answers. Or address more than one issue. If you ask 2 questions in a single survey question, it's called double-barreled. It's really hard for somebody to give a single answer to a question that asks 2 things. Here's an example. We want to identify what the issue is and how we could potentially correct it. A survey question asks, should the town build a playground and a dog area in the park on Main Street? Explain why the question may be biased or otherwise introduce bias into the survey. Then describe a way to correct the flaw. I want to be clear, the question you're being asked now is we're not being asked about the sampling method and the biases caused by it. We're being asked what about the question could cause biases. All right, so in this particular question, I could say that it's double-barreled. The question addresses more than one issue, so yes responses don't really indicate whether the person wants the playground or the dog area. Maybe they want both, but I can't really tell by someone simply saying yes. I could improve this survey question very easily by simply breaking it up into a couple different questions. Here's example 2. Explain why the survey question below may be biased or otherwise introduce bias into the survey. Then describe a correct way to flaw it, or a way to correct the flaw. Do you agree that our school cafeteria should switch to a healthier menu? Well, when you hear that question, hopefully you realize that it's kind of insinuating that you should agree. There's a difference between simply providing, do you agree or disagree, versus hinting that they should agree is kind of the option that they should go with. It definitely encourages a yes response. I could reword the question without leading as simply, should the cafeteria switch to a healthier menu? Or I could say, do you agree or disagree with the following statement? Okay. All right. Very, very heavy vocabulary lesson here today. Hopefully you're able to get some good notes and pause the video along the way to take a look at those U-tries. Go ahead and try the practice and then keep all of this information in mind for next week's Unit 3 Statistics Essential assignment, or maybe project.